Today we're looking at the area of what we call composite figures. So composite, remember, is just a combination of items. So we did composite transformations that were several transformations added together in order to create a more complex one. This is the same idea. Composite figure is some simple figures that are combined together to make a more complex shape. And there's two ways of looking at these. You can make a composite shape by addition or by subtraction. So we can take smaller shapes and add them together, or we can take bigger shapes and subtract away other shapes. So let's use this one as an example of talking through kind of the idea of today's notes. So I could take this shape. So I have 6, 6. Let's just split this here. And there's also not just one right way to split a shape up. So I'm going to split this one here and create this first shape, which is a trapezoid, because I'm drawing a line parallel to this base. Then I can split this one here and create a square as shape 2. And then finally, shape 3 is another trapezoid. I could have divided it differently, but it doesn't really matter how you divide it as long as you get it divided. So let's see. Shape 1, I have one base is 15, and then the other base is 15 minus 6, so that's 9. And then my height, do I know my height is 3? This is 6. Do I know? I don't know that these line up, though. Let's see. So I know this is 6. No, I don't. I don't know that's 6. Okay, well, we're going to go with the assumption that that this point is collinear with this line over here. Otherwise, we're not going to be able to do this one. So we're going to make that added assumption and say that this is 6 and 3. So my area of shape 1 is the average of my bases. So the average of 15 and 9 would be 12, and then my height is 3. So I have 36 for the area of shape 1. Shape 2 has a square that's 6 by 6, so it's also 36 because it's 6 times 6. And then finally, this trapezoid over here has a base of 6, and the other base is going to be 6 plus 6, so that's 12. The average of my bases is 9, and my height, which is so height is right here, is 15 minus 6, so that's 9. So I have 9 times 9 makes the area of this shape 81. So my total area is 36 plus 36 plus 81, and that's how we can find that by addition. So let's reframe it. I'm going to change pen colors, and we'll use something lighter. Let's use this green. And we're going to look at how we could think of this instead by subtraction. So I could start off here with a really big rectangle that goes all the way around the shape, and then think of removing shape 1, shape 2, and shape 3. So this one so this is a 15 by 15 square. So I have 225 minus, and now I'm going to take away these 3 small missing shapes that have been taken away from the big square. So down here, again, we're going to have to assume that this lines up, I think. I don't think there's any way to know that this 6 is actually aligned. So this is going to be 3 and 6. So I have a triangle with a base of 6 and a height of 3. That has an area of 9. Then I have shape 3. I don't know why I started there. Shape 2 has a height of 6 and a base of 9. So this base here is 9. So that would be 3 times 9 is 27. And then shape 1 is a 6 by 6 square, so that's 36. So let's compare. We have 225 minus 72. 225 minus 36 and 36, yeah, that's 72. So we have 183 units squared. And by addition, we had 36 plus 81. So that's 60, 72. That's, oh, I subtracted wrong. That's good. I got to double check. 72 plus 81 is 153 units squared when we did it by addition. And this should also be 153. I don't know how I got 183. I did 255 instead of 225. So this one should also have been 153 units squared. Great. So hopefully that kind of frames for you the idea of we can do these shapes by adding or by subtracting. And really, that's all the notes that there are for today. I kind of covered there. We'll do some example problems. But if you want to put something in your notebook and didn't already, we have a composite figure is made of smaller shapes or simpler shapes by adding or, well, let's put and or subtracting areas. So the two ways that looks, we could have a shape that's like this, where it's like a rectangle with an extra triangle over here, and then a hemisphere up here, and we can add those together. So 1, 2, and 3, and we do 1 plus 2 plus 3 to get the total area. Or we could have a shape where we start with something, and then there's like a missing piece, like here and here. And then usually what happens is they draw this as a shaded area. So they'll shade in the part you're supposed to find, showing you that these others are like holes or cutouts. And so if this is shape 1, 2, and 3, this would be 1 minus 2 minus 3. And we'll look at some examples of both of those, but that's the main idea, is we can add or subtract shapes. So find the area of each figure, round to the nearest hundredth. We're not going to do that unless, we're not going to do that. So we have a rectangle, shape 1, and a trapezoid, shape 2. The rectangle is 12 by 23, and by subtraction, we know that since the rectangle is 12 high, the trapezoid is 6 high. We also know that since it's a rectangle, this other base of the trapezoid that's not labeled is 23. So we're going to do this as addition because that's how it's shown, but we could also think of it as being one giant rectangle and take away those two little triangles. But we're going to do this one by addition, and we'll save subtraction for the next page. So our rectangle is 23 by 12. 23 by 12 would be, let's see, 23, so 230 plus 46 is 276. So that's shape 1 is 276 square centimeters, and then shape 2, halfway between my bases, the average is going to be 19, and my height is 6. So I have 19 times 6, which is 60, and 54 is 114. So we end up adding those two together, and we get 390 square centimeters. On the second one, we have two hemispheres. So here and here are two halves of a circle, and in between, we've added in a parallelogram. We can tell that because of these parallel arrows. So first I'm going to find the area of the circle, and I'm just going to find the area of the whole circle. So 1 plus 2 is a circle, which is pi times the radius squared. The radius is given as 6, so we're going to do 36 pi is the area of the two semicircles combined together. And then in the middle, our parallelogram has a height of 5, so that's shown here. And the base is going to be the diameter of the circle, which is 12. So we have 12 times 5 is 60. Now, as a precise answer, these two things don't combine. We have a whole number and a value in terms of pi. They're not the same size. So we can't actually simplify any further than doing 60 plus 36 pi. And then I'm going to put parentheses to show that my square inches applies to that entire quantity. We could also do 60 square inches plus 36 pi square inches, but that seems uglier to me. All right, the next one, there's a rectangle, a triangle, and a semicircle. The important thing here is to recognize the rectangle gives us the radius of 9 right here, meaning that's also a base of this triangle or the height of this triangle. And then we know that there's 9 here is the height of the semicircle. So we can break this 26 down into 7 and 9 is 16. And so this middle part is 10. So that gives us the rest of the triangle. So I'm not going to actually solve that one out. I just want you to see where the things come from. We don't need to do all the work for it. You can pause and do that yourself if you'd like. The next one looks like our diameter is 16, so we're going to have a radius of 8. That 16, though, is also going to be the base of a triangle. Let's see, we're going to make a right triangle here, and then we can find the height of this isosceles triangle using Pythagorean theorem. Because we have 8, 17, so the missing leg must be 15 because that's a Pythagorean triple. So now again we have all the information. We need to make sure we divide the area of the circle by 2. So my semicircle, shape 1, is going to be pi r squared, but half of that because it's only half the circle. So I get 64 pi over 2. 64 would be 32 pi for shape 1. Shape 2, I have 1/2 of the base of the triangle, so that's 8 times the height, 15, so that's 120. Or we could have written 1/2 times 16 times 15, and we get 120. So now we need to add those together. Again, we can't simplify between them because they're different sizes. So our answer would be 120 plus 32 pi with the units of square meters. Next one is pretty straightforward, I think. So we have the height of this triangle is 9.6. We have, I guess we need to find this by Pythagorean theorem. So we have blank 9.6 and 12. So we would find that with Pythagorean theorem. That's going to give us half the height of the square. And once we have that, we can find the dimensions of the square and the trapezoid. So let's move on to some shaded area problems. So these are framed as subtraction. Not that we couldn't do the other page by subtraction, but this one, they're intended to be done by subtracting. So the first one, we have a square minus a circle. We know that the square is going to be 25 squared, so shape 1, the square, and shape 2, the circle. We have 25 squared is 625, and then we have the fact that that's 25 means that's also the diameter of the circle. So if we do pi d squared over 4, then we have 625 pi over 4. So subtracting those, again, they don't combine because one has pi and the other doesn't. So we have 625 minus 625 pi over 4. Pi over 4. And our units are going to be square feet. So that's how we do the subtraction ones. We identify the large shape and then take away any unshaded parts. So this one will be 25 times 14 minus 1/2 of 25 times 11. So my big shape, 25 times 14. So that's 350 because I had 12 25s is 300 plus 2 more. And then we're taking away our triangle 25 times 11 over 2. Because 25 is the base of the triangle over here, and then 11 is the height of the triangle. So that's 275 over 2. So that would be 750, because I'm going to double this so I can put it over 2, minus 275. So simplifying that, I would get 475 over 2 square centimeters. And if I turn that into a decimal, it would be 237.5. Yeah. So, okay. This one relies on us knowing from chapter 10 that since this is the diameter of the circle, and this is an inscribed angle of that diameter, it must be 90 degrees. So then we can use Pythagorean theorem with 9 and 21.6 to find this diameter. We also then, so we can find the area of the semicircle using that diameter, and then we know the area of this triangle is 1/2 times 9 times 21.6. And then in number 9, we have a trapezoid. We again need Pythagorean theorem, so we're going to have to cut this trapezoid here and break this 37 down into 17 and 20. And then since we have a 20 and a 25, that should kind of look like a 3, 4, 5, because that's 4 times 5 and 5 times 5. So the height must be 3 times 5. So this is a 3, 4, 5 Pythagorean triple. You can also use Pythagorean theorem and solve for it if you don't recognize that. So 15 gives us the diameter of our semicircle, and then we have our trapezoid minus that semicircle. So remember, with the semicircle, you have to divide the area by 2. So that's some examples for today, and then you have different ones to practice in your booklet as well.